Distinguished guests, ladies and gentlemen, a very good morning from me. My name is Yong Soon Kong. I am from the Faculty of Applied Sciences, University Technology Mara. So today I'm going to share with you a little bit of information and also research that is conducted by myself in UITM. So the topic that I'm going to cover today is a very broad one, call it utilization of biogenic calcium for treatment of acid and toxic elements in soil. So before I go further, these are the presentation outline. First of all, I'm going to cover what is calcium. And to be more specific, there's only one material or two that I'm going to use today, which is blood cockle shell and palm kernel shell. There are two processes that are used to convert these material into value-added product, which are calcination and pyrolysis, and to be compared with the effectiveness in treating acid sulfate soil and also shooting range soil. So first of all, what is biogenic calcium? As you can see from the picture itself, it is calcium that is generated by living organism. Now, this calcium can be varies according to its different physiology and also whether it is a ocean organism or is a terrestrial organism. So there's one example that you can see right here, which is the bivalves, cuttle bone, and crustacean bones. These are calcium carbonate that forms the exo and endoskeleton of mollusks, crustaceans. But there's another one, which is hydroxyapatite, which consists of mainly the bones of animal. That includes fishes and the shells of the poultry eggs. Now, why these material are so important is that they contains primarily calcium, up to close to 90% of the calcium, and the different form also suits its different purpose. A calcium carbonate, it may be alkaline, but it releases its alkali slowly with acidic condition, whereas the calcium phosphate, which is the main ingredient of hydroxyapatite, may also allows the slow release of phosphate to fertilize the soil. And at the same time, it may be also used for immobilization. Now, these materials can be calcined. Now, when I say calcination, it involves high temperature up to 900 degrees or above. And that is also the truth for these materials as well, whereby oyster shell, green mussel shell, and blue shrimp crab, they all can be calcined at 900 degrees Celsius, whereas cuttlebone at 700 degrees Celsius, being a less dense calcium carbonate here. Now, moving on, this is the work that is done in Malaysia. And why Malaysia? We have a lot of good food. So the image that you can see on the top right is a dish called char kway teow, which is a noodle that is fried with a lot of blood cockle shell. And hence, that is the motivation. Because with such a popular dish, it will generate a lot of shell. So there you go, blood cockle shell. That has been generated in relatively large amount and of no use, because what do you do with the shells? You just throw it into the seaside and let it decompose. Now, weathering is a good way of removing the organic matter. What you can see on the bottom right here, is the weathered blood cockle shell, in which it appears completely white. Now, the original shell of blood cockle is not that white unless it is stripped of its organic material, its flesh and organic material. And these are the materials that are readily to be used for soil remediation. Now, why this is good? Because it consists primarily, once again, calcium carbonate up to 93%, and this material can be used directly for liming marginalized soil, acidic, or maybe contaminated soil. Now, according to a research done before by a fellow Malaysian, they discovered that blood cockle shell uh, can be decomposed at a relatively low calcination temperature, which is 830 degrees, as compared to limestone, which is usually 900 or maybe 850, the lowest. By comparison, they are slightly lower because this calcium carbonate is in a form of aragonite, which is an amorphous form of calcium carbonate. So therefore, in order to calcine them, because of the porous structure, it is relatively easy. And this part is the one that I have done some preliminary study just to investigate the potential of blood cockle shell as a source of biogenic calcium. Now, To begin with, this material has been compared with a lot of calciums coming from the commercial liming agents such as dolomite and also ground magnesium limestone, and also other pure chemicals such calcium oxide and also calcium carbonate. So the materials that I have used is blood cockle shell. So 1.0, they are completely pure blood cockle shell, and the mixture with palm kernel shell. Now, for your information, for those who have no idea what is that, that is the shell of the fruit, the seeds of the fruit, which have no which have no commercial value before that. But nowadays, because of the oil content in it, it has been used for combustion to recover its calorie, the remaining calorie that stays in those shell. Now, there's an interesting fact is that this shell has a high silica content, up to 55% in its palm kernel ash. Now, there's a say that silica, if you can use it back, it can be used for so many things. It can be used for cement, for nanosilica, for various applications in cosmetics. So they are useful. And hence it is used to be mixed and calcined together with uh, blood cockle shell. And the key point is that, as you can see right here, blood cockle shell, the acid neutralizing capacity that measures how much of capacity that this material can neutralize the soil is displayed right here. So the unmodified form, the uncalcined form, is on par with ground magnesium limestone. In fact, exactly the same. Yeah. And what's interestingly is that once it is calcined, the acid neutralizing capacity double compared to the uncalcined form, blood cockle shell. Now, even more interestingly, if this material is blended with equal amount of palm kernel shell before calcination, as you can see right there, not very good. But after calcination, the acid neutralizing capacity comes nearer to the calcined blood cockle shell, but there is a catch. Remember the silica content? It is combined with the possible formation of calcium oxide. So the interesting fact is that what will the silica or the silicates in the palm kernel shell, how would they react with the biogenic calcium? Now the answer would be nothing will happen as long as they are in dry form. And during calcination, that is exactly the case. However, when this material, the co-calcined blood cockle shell and palm kernel shell, is used in moist soil, something happened. Now, I want to bring your attention to this graph right here, the green curve. So the green curve represents calcined blood cockle shell. Most likely, the chemical composition inside there is primarily calcium oxide, the product of calcination. Now, once it is applied into soil, it immediately increases the soil pH, but then crash down to its baseline. However, if you compare to the red lines, the red curve, that is the co-calcined blood cockle shell plus palm kernel shell, the one that contains calcium oxide with silicate. And as you can see right here, the soil pH is relatively stable throughout the entire duration of the experiment. That gives you a hint that the silica is in play in a way that it maintains the soil pH, it elevates the soil pH, but maintain it at a manageable level. Now, unfortunately, we did not extend the experiment to see the long-term pH in the soil, because we suspect that it may also make it last much longer. Unfortunately, we only do this in 21-day interval. So therefore, we can estimate that the silicate is doing something. Now, coincidentally, a colleague of mine in UITM on the Northern Park branch campus, she also conducted similar experiment, but this time they are looking at its application in cement. And surprisingly, she mentioned one word, which is calcium silicate and the calcium silicate hydrate to be more exact. Because once this material is moistened, like in this case, applied in moist soil, and in her case, is being mixed with water in the right amount to becomes a mortar, a pozzolanic effect is observed in a way that once again, the presence of silica mixed with calcium forms calcium silicate, and this is actually a pozzolanic material. So that might explains the reason why the stable soil pH after application of this co-calcine, blood cocoa shell and palm kernel shell. So furthermore, this same material has been used to treat acid sulfate soil. Now, it is well known that acid sulfate soil is acidic, as the name says itself, but because of the acidity, some of the geogenic elements that may be toxic, such as aluminium, may be made available and cause toxicity towards the plant. And in Merbo, that is a case in which aluminium toxicity of the acid sulfate soil reduced the paddy yield. Now, that is a research done by a colleague in UPM, which is reported in 2014. Now, the one research that is done by myself is I compare the effectiveness of liming agent, different kind of liming agent, one that is ground magnesium limestone, the commercial one that is used primarily by farmers, and another one that is produced by me, the co-calcite, blood cocoa shell with palm kernel shell. And the result shows that it is much better in lowering the exchangeable aluminium. So in this case, the untreated acid sulfate soil, the exchangeable aluminium is up to 7.6%. After treatment with ground magnesium limestone, it comes down to 2.4. But with co-calcine blood cocoa shell with palm kernel shell, it comes down even further to 0.16%. So that shows that liming with calcine, biogenic calcium, together with palm kernel shell, it brings more value and its capacity to reduce and remediate toxicity of marginalized soil, in this case, acid sulfate soil. Now, when we look at the potential in treating acid sulfate soil, I want to compare one research that is done by a colleague of mine in UM. Yeah. So according to this paper published by her, Abdul Halim et al. 2018, the addition of GML increased the soil pH, and it is discovered that this soil pH level is exactly the same, similar to the co-calcine, blood cocoa shell, and palm kernel shell. The pH raise is 5.6, which is relatively okay for paddy growth, and then it creates a favorable soil conditions for rice cultivation and possibly may lead to improved rice growth. Now, the average height of the paddy grown and reported by this paper treated by GML is much better compared to the compost and basalt and biochar materials that is being used at the same time reported by this paper. So GML is the best. Yeah. And as a result, it can be deduced that co-calcine blood cocoa shell may also perform the same, if not better, because of its ability to reduce the exchangeable aluminium, and it also can be used to treat acid sulfate soil. However, this research is not done, so it is open for many researchers to do if they are interested. However, the next part, now we have been talking about calcination, but we forgot to mention about its energy intensive process. So yeah, it is. Calcination requires intensive use of energy, and financially and environmentally speaking, it is not really a sustainable approach given that the many fuels that is required on energy intensive process. So thereby, another alternative that we may be able to consider is the pyrolysis. Now, pyrolysis is still a thermal process, but at a relatively lower temperature, say 600 degrees Celsius. That is good enough. But you can ramp it up to 900 degrees, which is not necessary, but up to the requirement of the remediation plant. Now, the other condition that is required is at low oxygen environment. That is relatively easily manageable. Just restrict the flow of oxygen, it will do its job. Now, a process where it will carbonize the biomass already in the mixture, so possibly palm kernel shell, it may be turned into biochar, and it may allow the partial calcination of biogenic calcium. So you got both, yeah? You got biochar and also some calcination in the calcium. Yeah? So conventionally, ground magnesium limestone or burn lime has been used to immobilize heavy metal. Now, those are minerals that increase the pH, and that's it. It does not do anything else. So imagine if the soil is limed constantly with all this material, particularly marginalized soil. Now, usually soils that suffer stress and toxicity would usually have very little vegetation, and as a result, the organic matter, it's naturally low. Now that gives us some concern because constant liming might going to exacerbate its problem. It might going to decrease further the organic content, given that the caustic nature of this liming agent, and for sure it will going to deplete the organic matter. So as a result of it, co-pyrolysis, that means pyrolysis of these two material, the biogenic calcium and also biomass, might give us two materials in this one composite. The partially calcined liming agent, the biogenic calcium, as well as recalcitrant carbon. Now, recalcitrant, why is so important is that it is relatively resistant to breakdown, either by oxidation or, and in this case, the effect of the caustic effect coming from the liming material, the biogenic calcium. So that might be some thoughts for us on how to have a more holistic and more complete approach towards soil remediation. So another case study that I've done is on the Malaysian shooting range soil. So as reported by many literature, it contains a high level of lead. But in Malaysian case, it is also sandy with low clay and silt content. And what's worse is that it is also coming with a very low organic content. Not surprisingly, because of the nature of the shooting exercise, no vegetation can grow on the slope. But when we look carefully at the bottom of this slope, it is also equally barren. What's explained this is possibly due to the extremely high available lead coming down from the slope. Given that no organic matter is there to hold those exchangeable lead, and at the same time, there's no nutrient, there's no organic matter where the plant can survive, and hence the barren land. So this research is conducted in 2020 by one of my students, in which she have combined the biogenic calcium, which is blood cockle shell in this case, together with palm kernel shell, and she pyrolyzed it. Instead of calcite, she pyrolyzed it to get a composite biochar. So in this case, this composite biochar is called CPB, and is prepared in various conditions, various formulation, and at the end of the day, we found out that we're going to choose CPB9, which is right here, prepared with one part of palm kernel shell and also one part of blood cockle shell, heated with 1 hour, pyrolyzed, sorry, in 1 hour, at a peak pyrolysis temperature of 900. And as a result, the pH of that material is also quite high, 12.5. Now, the high pH of this material possibly is mainly due to the presence of calcium oxide. Now, given that the high temperature, this is exactly the calcination temperature. Yeah. So the remediation of soil is carried out using CPB9 once again. It increases the soil value, the soil pH value, and at the same time, it decreases the solubility and mobility of soil Pb. And as a result, it brings about the immobilization of the lead inside the soil. Now, this result indicate that CPB is effective. It increases the soil pH at a relatively high level, which is probably not that ideal for plant growth, 9.1 or to 12. But this amount can be adjusted, in which later on for field application, a lower content of CPB can be applied just to make sure that the soil pH is at the optimal level of 7, maybe 8. Yeah. So after incubation, the exchangeable lead, yeah, decreased from 7.56 to close to zero after treatment with CPB. And the carbonate fraction is also reduced from 0.51 to 0.15. So that tells us that this lead is changed not to calcium, not to lead carbonate, but rather something else. What could it be? We run a further experiment on the selective sequential extraction, and we just discovered that yes, CPB increased the pH. However, majority of the lead is actually complex or coordinated to the biochar, the organic part. And that shows right here, CPB treated soil, the whole yellow section for organic section. So that gives us an idea that this lead, instead of precipitated, it is immobilized and absorbed in the biochar. So that gives us some surprise because we thought that it will work more as a liming agent, but in this case, the biochar becomes a more dominant mechanism in immobilizing the lead. So the key point is that biogenic calcium, in this case, has been an activator to activate the biochar instead of it reacting itself as the liming agent. So the conclusion is that biogenic calcium is a renewable material with a very high potential compared to limestone because it's renewable. And because of its amorphous nature, it can be processed relatively easy. And so in this case, while we still going with the thermal process, given of the high alkalinity it may give, this process may be expanded to blending with other minerals such as kaolinite or maybe expanding clay that may enhance its sorption capacity, but also can be blended with manure that introduce more nutrient to the soil, and as I said earlier, a more comprehensive regeneration of the soil that involves the soil biology. Yeah. Okay, biomass with high silica content, and in this case, high calorific value of palm kernel shell can be used to enhance soil carbon by introducing more biochar at the same time immobilizing the heavy metals in the soil. So biogenic calcium can be used in the scrubber of the many biomass-fired power plant across China. Now, China imports a lot of palm kernel shell from Malaysia for this purpose. So why not consider using this biogenic calcium in their flue gas scrubber, in the fluidized bed reactor? At the end of the day, the entire bed can be used as a material for liming contaminated soil. So with that, that is the end of my presentation. But before I end my talk, I would like to acknowledge and thank uh, the Malaysian government, particularly the Ministry of Higher Education for providing the research fund, the Ministry of Defense for allowing me to access their camp and also collect soil samples from their shooting range, the Malaysian Soil Science Society for the support and recommendation to participate in SOILREM, Perlis Dolomite for providing the materials, dolomite and ground magnesium limestone for this research, and last but not least, Professor Jing Song and the entire SOILREM organizing team for the assistance in making this happening. Now, I would like to convey my sincere apology to Prof. Jin Song for not being able to attend this physically due to unforeseen circumstances. Uh, but but yeah, thank you very much nonetheless for this opportunity. So before I go, one last promotion that I would like to give for the Malaysian Soil Science Society. Now we actually have a conference very similar. It is named International Soil Science Conference, happening in 14th and 16th of May in Kuantan, Pahang next year. So plenty of time. If you're interested, please scan this QR code or visit this URL for more information. All inquiries regarding this conference should be directed to the emails as stated below. So with that, I thank you for your attention. So hope to see you again in the future. Thank you very much.